Welcome to expert tutorial. So today we will discuss about the principle of dimensional homogeneity and we will do some examples. So let's start. So principle of homogeneity states that the dimensions of each terms of a dimensional equation on both sides are the same. So there can be a comparison in between two or more physical quantities of the same nature, but we cannot compare between a length of 5 meter and a mass of 20 kg. So can we compare that? So absolutely no. So we can only compare the quantities of same kind. So in other words, we can say that only those physical quantities can be added or subtracted which have same dimension. So this is basically the principle of homogeneity. So if we say that equation a plus b equals to c, then the right hand side and the left hand side both have the same dimension. So this is the principle of homogeneity. So if the two sides of an equation formed by the physical quantities have the same dimension, the equation is said to be correct. And this is the principle of dimensional homogeneity. Now, what is the application of this dimensional analysis or dimensional homogeneity? So there are different type of applications. So the first application is to check the consistency of a dimensional equation. So if we want to know that the equation is correct or not, then we use this dimensional analysis. And to derive a relation between physical quantities in physical phenomena, and also to change units from one system to another system. That is, if we want to change one unit from SI system to CGS system or vice versa, then we use this dimensional analysis. Now there is an equation that v equals to a plus bt, where v is the velocity and t is the time, and a or v is you have to find the dimension of a and b here. So what we will do? So just to remind about the previous lesson, that is dimensional homogeneity, principle of dimensional homogeneity, that only these physical quantities, only the physical quantities can be added or subtracted which have same dimension. So here we can say that here v is the velocity, and t is the time. So here v is the velocity and t is the time. So here we can say that the dimension of A should be equals to the dimension of BT, and that should be equals to dimension of V. So the dimension of A should be equals to the dimension of V, as we cannot add or subtract any two parameters which have different type of dimension. So if we are adding a plus bt, that means this a and bt have the same dimension, and also if this equation is right, then we can write as v minus a minus bt equals to 0. So from this we can tell that the dimension of v should be equal to dimension of a, and that should be equal to dimension of b into t. So the dimension of a equals to dimension of v, and we all know that the dimension of v, that is the velocity, is L by t, that means L t to the power minus 1. So the dimension of a equals to dimension of v, that is L t to the power minus 1. So dimension of a equals to, if we write in the traditional form, then m0 L1 t to the power minus 1. And now coming to the second part, that is bt. So the dimension of b into t equals to dimension of v. So v into t, that means the dimension of t is capital T, so L t to the power minus 1. So the dimension of b equals to L t to the power minus 2. So the dimension of a is m0 L1 t minus 1, and dimension of b is m0 L t to the power minus 2. Now coming to this equation, v equals to a plus b by t plus c, where v is the velocity and t is the time, and you have to find the dimension of a, b and c. So according to the principle of dimensional homogeneity, the dimension of t and dimension of c, this one, will be same, as we cannot add t and c if the dimension is different. So we can add t plus c only if the dimension of the both is same, so that we can conclude that the dimension of t should be equal to dimension of c, and that's why we can add them. So do not worry about this kind of equation, as we can add them. Only you have to remind that we can add or subtract any two physical parameters if and only if their dimension is same. So the dimension of c, we can easily write that the dimension of c should be the dimension of t, and it is capital T. Now another one, that is the dimension of a should be equals to dimension of v. So the dimension of a should be equals to dimension of v, and the dimension of v is the dimension of velocity, that is L t minus 1. Now what about the dimension of b? So the dimension of b by t plus c, this is equals to the dimension of v, that is L t minus 1, that is the dimension of v, velocity. Now we have already calculated the dimension of c is capital T, so the dimension of the t plus c is capital T. So just put the values, that is b by t equals to L t minus 1, and the dimension of b should be equals to L. So by this way you can calculate the dimension of any unknown parameter if we use this dimensional analysis. And now the limitations of dimensional analysis, that is the dimension does not depend on the magnitude, and due to this reason the equation, that is x, if we write the equation as x equals to ut plus at square, it is dimensionally correct, but the real equation is x equals to half at square. So a dimensionally correct equation need not be actually correct. This is somehow the limitation of the dimensional analysis. Also, the numerical constants having no dimensions cannot be deduced by the method of dimension, as you can see that the in case of Newton's law of gravitation, it contains the capital G, which is not dimensionless. So, and also the formula containing the trigonometric equation, exponential functions, logarithm functions, etc., it cannot be derived from the dimensional analysis, and it also gives no information about whether a physical quantity is a scalar or vector. So these are some drawbacks or limitation of the dimensional analysis. So thank you everybody.